Okay, here we are with our last day of 4.4, which was solving exponential and logarithmic equations. This happens to just be focusing on the logarithmic. The first 2 days were exponential. So the notes from the book, logarithmic just means that it contains logs. So again, whether it is this log log or my natural log ln, which has the base of e, we can use either of them. So this was what we did in the second day's lesson, working in the other direction, that we can just use the definition of a logarithm. So basically rewriting it as an exponent and then just solve. One of the things that we have to watch for, though, that we didn't worry so much about before, is that we have to check our answers to make sure that we end up with just positive values and throw out any negatives that we might end up with. So in solving the logarithmic equations, and I'm just going to work through these two examples. So for A, if we have log base 4, go to my regular black pen, A is log base 4 of x plus 3 being equal to 2, which means if I rewrite this as an exponent, the base is 4. The log is always equal to the exponent, so it just becomes 4 squared equals x plus 3, which means 16 is x plus 3. And if I subtract 3 from both sides, I end up with x equals 13, which I can easily check as well to see that that answer makes sense. Okay, in example B, we have 3 times the natural log of 2x equals 12. So this, similar to what we did in day 2 of the lesson, we really can't do anything until we have that natural log isolated. So get rid of that 3 by dividing, since it's just the coefficient in front being multiplied. So the natural log of 4. And if we rewrite this, remember that the natural log is base e. So it's really a base of e to the 4th equals 2x. We're going to end up with a decimal point, so divide both sides by 2. And whenever you do that in the calculator, I just did e to the 4th divided by 2 all in one step. And I'll round it to 27.3 because it's 27.299. So we'll just call it 0.3. So those two examples. We also will have to use some of our properties where we condensed and expanded logarithms. And so the one-to-one property that's listed, just recognizing again that we have to check all of those answers. And then example 8, I have, again, only a partial screenshot of. So if we have solving this one, and this one gets kind of tough, we're subtracting the natural log of those two. We have a single log on the left-hand side by applying the rule. And then if we have the natural log of x plus 2 over 4x plus 3 being equal to the natural log of 1 over x, then we could solve x plus 2 divided by 4x plus 3 equals 1 over x. We would cross multiply. So we end up with x times x plus 2 equal to 1 times 4x plus 3. And so when I distribute that, I get an x squared. It's been so long since we've seen a quadratic. Distribute the 1. If I move the 4x and 3 to the left-hand side by subtracting a 4x and a 3 from both sides, then I end up with x squared minus 2x minus 3 being equal to 0, which I can, in fact, factor. So this would give me x minus 3 and x plus 1 equal to 0. And so I have either x equals 3 or x is equal to negative 1, which, again, in order to check those answers, being careful that I have positives that m and n were greater than 0, I have x equals 3 as an answer. That was supposed to be in blue. X equals 3 is an answer. So the homework that was here, and since we did a couple of those other class examples, let me scooch these down. Oh no, I didn't want to move the whole thing. All right, maybe we won't move them all. I'm learning how to use my new whiteboard, in case you couldn't tell. The homework was supposed to be page 457. And it's just because these problems get rather long, 52 to 88, multiples of 4. So that we don't have so many. Again, making sure that we reject any value not in the domain. So looking for those positive answers, exact answers if we can, otherwise using the calculator and figuring out what those decimal points are. So we'll take a look at just 2 of these since we have already done those book examples. So why don't we take a look at number 68. It's right here at the bottom anyways, so that makes it easy. So for number 68, they're both log base 2. And this addition sign here in the middle. If I have 2 logarithms that are added, I should be multiplying those instead. So I would have the log base 2 of the product of x minus 1 and x plus 1 equal to 3. And if I then rewrite this in exponential form, so 2 cubed, the base of 2 and the exponent of 3 would be equal to this quantity. 2 to the third is 8. If I FOIL this, or if I recognize it as the difference of 2 squares, I end up with an x squared, a plus 1x on the outside, a minus 1x that's going to cancel. So again, if you recognized that and skipped writing that entire thing out, that's just fine. I have x squared minus 1 equal to 8. I can solve this 2 different ways now. I could subtract the 8 from both sides and end up with, I'm just going to rewrite it. Whoops. If I subtract the 8 from both sides, then I end up with 0 equals x squared minus 9. And recognize that is another difference of 2 squares. So x plus 3, x minus 3. And if I said each of those equal to 0, I would get a negative 3 and then a positive 3 for my answer. So, or if I instead add a 1 to both sides, then I end up with 9 equals x squared, and then I can solve this by undoing, by taking the square root of both sides, and then I end up with x equals, when you take the square root of 9, either positive or negative 3. Okay, now if I check the positives and negatives here, what's going to happen when I plug that negative in is that I would have log base 2 of negative 4, negative 3 minus 1 is negative 4, multiplied by negative 3 plus 1, which is negative 2. So I'm actually going to take log base 2 of a positive 8. So it works on this one to have both the positive and the negative listed there for me. Let's, for our last one, we already did something similar to 88 with that example. So let's take a look at number 84 instead. And then this will finish up 4.4. So 84 log, this is a common log because I don't see any other base listed there. So it's understood to be a base 10 of x minus 2 plus log of 5 equals the log of 100. So again, since they're added, I'm going to write this as one logarithm multiplying the 2 things. So x minus 2 gets multiplied by 5. That 5 is going to have to be distributed. And that's equal to the log of 100. So the x minus 2 times 5 must be equal to 100. And so really I could distribute the 5, or I could just divide both sides by 5 at this stage. So if I distribute it, would be 5x minus 10 being equal to 100. Or if I wanted to divide both sides, I would end up with x minus 2. 100 divided by 5 is 20. So if I add 2 to both sides, I can get a 22. Or if I add a 10, so that 5x is equal to 110, and then I divide by 5, I can end up with my 22 from that direction instead. Neither one's really more or less work than the other. So again, a lot of recall needed in these problems. So we are pulling together our rules with logarithms for expanding and condensing, and then algebra rules that maybe it's been a while since we've done some of these tougher solving problems. So trying to remember and pull all of those pieces together. And that's the end of 4-4. So really 3 different types of problems that we solved.